Hello, how are you? Good morning, good afternoon, good day, wherever you are watching from. I hope you're having a great day so far. So remember, we were continuing to discuss about the importance of doing experiments in statistics because we want to find the effect of an explanatory variable on a response variable. Explanatory variable, something that explains the results. For example, we discussed it last time uh, that suppose I'm teaching statistics in two sections, one at 3 p.m., another at say 10 a.m. in the morning. Okay, same material, so I'll have the same test on in the two classes. One class I will maintain at the normal room temperature, the other I will cool by say 10 degree Fahrenheit. So what is my goal? What will be the effect of the room temperature on the student performance in the exam? Notice, however, there's something going on. One of the classes is in the morning, another class is in the afternoon, 10 a.m. and 3 p.m. This may be a extraneous variable. An extraneous variable is something which can confound or confuse the results. To remove the effect of the extraneous variable, I have to do the testing in the two sections, same material on during this at the same time, maybe 3 p.m. in the afternoon. We discussed all this. Now I want to discuss a little bit more about how to devise experiments for statistics. Again, just to make sure that you're on the same page with me, we want to design experiments for statistical studies because I want to see the effect of one variable or one factor or more factors on a response variable. Response variable is the final results or outcome variable that we are looking for. So, without further ado, I'll get started. But before I get started, please stick through the end of this video. It is a short video presentation. It is in uncut version, and I will keep it short and sweet. And please do not quit halfway through. If you like this video, please give me a thumbs up. If you like this video, please subscribe to my channel by hitting the red subscribe button. So let's go to the nitty-gritty details. So I'll share my computer screen with you. Okay. So last time we talked about experimental design, how to design experiments for statistical studies, as I told you. But what is the catch here? Today we are going to talk about how to devise an experiment, how to design an experiment which will give us some important information. The goal of an experimental design is, let me move this stuff a little bit up, is to provide a method of data collection that minimizes the effect of extraneous variables. Remember, I started this presentation with the fact that if I have two sections of the same class, one in the morning, one in the afternoon, time of the day may be an extraneous or outside variable which can affect the outcome variable or confound the results. To minimize the effect of extraneous various sources of variability in the response so that any difference in response for various experimental conditions can be more easily assessed, and creates experimental groups that are similar with respect to extraneous variables that cannot be controlled either directly or through blocking. If the purpose of an experiment is to determine whether some treatment has an effect, it is important to have an experimental group that does not receive the treatment. Such a group is called control group. Now we are talking about two groups. Get that straight. One is a control group that does not get the experimental treatment. The other group gets the experimental treatment. Why do we use a control group? Because that's a reference point. The use of a control group that allows the experimental to assess how the response variable behaves when the treatment is not used. Okay, so it's a reference group that shows us how the response variable will behave if the treatment is not used. This provides a baseline against which the treatment groups can be compared to determine whether the treatment had an effect on what? On the response variable or on the outcome variable. Suppose that an engineer wants to know whether a gasoline additive increases fuel efficiency miles per gallon. The experiment might be to use a single car to eliminate car to car variability and a sequence of trials are experiments, in which 1 gallon of gas is put in an empty tank. The car is driven around a racetrack at a constant speed, and the distance traveled on a gallon of gas is recorded. That is your baseline. Understand? That's your baseline. Because this is 1 gallon of gas in an empty tank without any additive added to the gasoline. Would you be able to determine if the additive increases the fuel efficiency if there were not trials where the additive was not used? Remember, in the previous slide, we talked about the situation where we ran the car with a tank of 1 gallon of gas without any additive. That's your baseline. That's your control. That establishes the baseline from which next time around we can add add the additive to the gasoline and see if it changes the fuel. That changes the miles per gallon. What does it mean? From the base, we'll compare the baseline performance with the additive performance. Is there an increase in miles per gallon? That is the whole question. Answer: to determine whether the additive increases the gas mileage, it would be necessary to include a control group of trials in which distance traveled was measured when gasoline without the additive was used. The trials would be assigned at random to one of the two experimental conditions: additive or no additive. No additive is the control group, is the baseline. Okay. Control group limitations. In experiment with human subjects, relying solely on a control group may not provide conclusive evidence of treatment effectiveness. People can respond to power of suggestion impacting study outcomes. What are they talking about? Okay, think of the situation. This happens in real life. Okay, I stress that drug company, medical company, medicine company, they come up with a new experimental drug to cure a difficult disease. Okay, so they will have two groups in their study. One will be the control group, which will get the actual existing medicine, and the other group, okay, will get the new test, the new medicine. Okay, so control group compared to the experimental group. Okay, the what they're saying in the first bullet, the control group, which is the group, sometimes it is also devised like this: the control group is the group which gets a pill very similar to the experimental group, which gets the real pill with the actual medicine in it, new medicine, test medicine in it. And the control group gets a exactly similar looking pill, but it is a placebo. It's a placebo. What is a placebo? It's a sugar pill. Does not have the actual medicine in the pill, but it looks exactly like the test pill. So, control group limitations, what they're talking about, if people come to know who are participating in the control group that they're getting a control pill, which is a placebo, which does not contain the actual medicine, then, after knowing that they have been given a placebo, they might be psychologically influenced by the fact that they're not getting the actual medicine. Okay. People respond to power of suggestions. Placebo effect. People often respond to treatments lacking active ingredients. Okay, studies show that individuals report pain relief or symptoms reduction even with placebos. Okay, sometimes the people also tell that their pain is reduced even if they have been receiving a placebo. They're in the control group. So what is a placebo? Something that is identical in appearance, taste, feel, etc. to the treatment received by the treatment group, except that it contains no active ingredients. So let's think for a minute. What is a placebo? In the situation that I discussed, two groups, one control group, one that get the real medicine. The two pills in the control group and in the test group look exactly identical from outside. In taste, in smell, everything is exactly identical. Only the control group, which gets the placebo, that is a sugar pill, does not contain the real medicine. And the control group is used to establish a baseline from which, if the results from the control group are compared with the results from the group that got the actual medicine, then we will be able to determine whether the new medicine is beneficial in curing the actual disease. That's the whole point, comparing it to the placebo. Now, think of the situation as I discussed before, that if people who are participating in the test know exactly what they're getting, are they getting the regular pill, that is the placebo pill, or are they getting the new test drug inside the pill that they're taking? What happens if they know whether they're getting the placebo or the real test pill containing the medicine? As I told you before, these people may be influenced because it's a psychological effect. Why? Think about it. If you know beforehand I'm getting a pill which does not contain any medicine, why would I think that I get cured? Okay. The opposite also might happen. Some people might report that they're getting cured even if they're getting a placebo pill, which is a sugar pill, does not contain the active drug. So there are problems. If people know, people who are participating in the study, the volunteers who have been recruited to participate in a study, to test the effectiveness of a new drug, know beforehand what type of drug they're getting, actual or the placebo. Okay, so that is what we are going to discuss now. Okay, why it is not beneficial for people to know beforehand, volunteers to know beforehand what they're getting, the actual pill or the placebo pill. So here they're talking about a herbal supplement. Herbal supplement, hopefully to improve some medical conditions. Of course, with all this test, to test the new medicine, herbal supplement, we should have a control, okay, which is a group that will get the placebo without containing, which would not contain the herbal supplement. Okay. In the herbal supplement experiment, a placebo group taking a pill identical to the supplement but without active ingredients serves as a comparison to assess the actual impact of the supplement. Blinding participants about their intake helps distinguish genuine effects from the placebo effects, enhancing the study's validity. What does this last sentence mean? Blinding means you are not going to tell the participants or volunteers who have been recruited to participate in this study, where we are comparing the effect of a new herbal supplement to regular pill without the herbal supplement. If you tell them beforehand that some of the participants are getting the placebo pill without the active ingredient, they will get psychologically biased, okay? And that might affect the results, that might affect the conclusions based on the study. So there are two kind of blindness. Okay. I told you before, and we are going to discuss why it is important not to reveal what the actual participants are getting, whether the real pill or the placebo pill. Remember, from outside, the pills look identical, they test identical, only one has the active ingredient, the other does not. So what is a single blind experiment? Subjects are unaware of the treatments they receive. Subjects means people who have been recruited, volunteers who have been recruited to participate in the study. Prevents personal perceptions from influencing responses. Again, we did not get them biased to get biased. Limitation not feasible in all experiments. Example comparing two types of exercise on blood pressure. Okay. Think about it. If you suggest to the patients, divide the patients into two groups, and one group gets a more rigorous exercise and the other group gets a little bit less rigorous exercise, you would think the group which is getting the rigorous exercise, set of exercise, will improve their blood pressure quickly. So here you cannot really blind the participants because they already know which type of exercise they will do and what will be the effects. More rigorous, greater chance of reducing blood pressure significantly. So we talked about single blind experiment in which a placebo is used looking identical to the real pill, but the volunteers who are participating in the study do not know in which group they fall, the group taking the real pill or the group taking the placebo pill. Single blind means only the participants do not know, the subjects do not know. But again, then we discussed for some situations like exercise, you cannot really blind them. Then there is a situation called double blind experiments. Okay. So double blind experiment, an experiment in which neither the subjects, that means people who are participating in the study, the volunteers, and those who measure the response know which treatment was received. Measure the response means nurses, doctors who are conducting this study. They also do not know which group they're testing, which patient has received which kind of medicine, the real pill or the placebo pill. One day in a class, somebody asked me, who knows what the patients are getting? Is it the real pill or the actual real pill or the placebo pill? I told them there is always an administrator on top of these experimental people who are doing the research. On top of the researchers, there is an administrator. So researchers are here, the administrators are there. It is the administrators who know which group has gotten which kind of pill. Since the researchers do not know what pill has been given to which patient, and the patients do not also know what pill they have gotten, the real pill or the placebo pill, this is called a double blind experiment. Okay, double blind, two sets of people do not know the correct information. Single blind experiment, an experiment in which the subjects do not know which treatment was received, but the individuals measuring the response do know what the treatment was, which treatment was received, or in one in which the subjects do know which treatment was received, but the individuals measuring the response do not. So, double blind, two sets of people do not know what type of treatment is given, the regular, the control pill, or the placebo pill. Again, the advantage of blinding or not divulging the true information is to reduce the effect of bias. If people knew beforehand what type of pill they are getting, the real pill or placebo pill, they might get psychologically influenced. Same with the experimenters. If they know which patients they're studying, which patient got which pill, they also might get influenced. So the purpose of blinding is to prevent biasing of the results. Okay, that is the bottom line. Experimental units and replication. An experimental unit is the smallest unit to which treatment is applied. In the situation we just discussed about testing a new drug, of course, the experimental units are volunteer people who have been recruited. Okay, so experimental units are people who are participating in the study, the volunteers. Replication, applying each treatment to more than one experimental unit, helps understand variability in response values for individuals receiving the same treatment. Lack of replication may hinder determining differences in response between treatment groups. Replicating an experiment involves conducting a new experiment with the same design. Replicate means do it more than once. And you know, the control med pill and the test pill should be tested on more than one individuals at any one time. And this process should be repeated a number of times. Why do you want to replicate? Why do you want to repeat the same study again and again? So that all the variability is ironed out. Variability in the results is ironed out from person to person. And if you keep the double blind, then also you will find the actual result, whether the actual new medicine is actually curing the disease it's supposed to cure. That's why we keep it double blind. And we replicate so that the variability that we get from one person to another person is ironed out, because we are repeating the same experiment with a number of volunteers, more than one, definitely much more than one. Although the use of volunteers in a study that involves collecting data through sampling is never a good idea, it is a common practice to use volunteers as subjects in an experiment. Even though the use of volunteers limits the researcher's ability to generalize to a larger population, random assignment of the volunteers to treatment that result in comparable groups, and so treatment effects can still be assessed. Ideally, we should not be used volunteers, right? Volunteers may want to participate because they might have an hidden agenda, they might be already very sick. But if we randomly assign the volunteers who want to participate in the study to the two different groups, remember the control group, the placebo group, and the actual test group, which contains the real. If we do not tell the volunteers what group they are participating in, also the people who are doing the study, the researchers, they also do not know which volunteer or which person is participating in which group, then we might expect the results to clearly show the effect of the new medicine. Whether it is different, the results are different from that group that is receiving placebo, that is the control group. Okay, remember placebo is a sugar pill. The key thing is from outside it looks the same as the real pill. Also from test it looks the same as the real pill. Okay, so we stop here today. If you have any question, please write me in the comment. And please let me know in the comment where you are watching from. I'm really curious to find out where you are, uh, listening from. Please let me know that. And if you like this video, please give me a thumbs up. And if you like this video, share with your friends. Please subscribe to my channel by hitting the red subscribe button at the bottom right corner. And also, please do not forget to click on the bell button, because that will notify you every time I upload a new video, which is almost every day. And I appreciate the fact that you're taking time to watch this video. And please do not forget to watch me tomorrow when I'll be back with another new material. Again, thanks for watching, and please keep those comments coming. I really appreciate that, and please give me thumbs up if you like this video. That really motivates me. Again, thanks for watching. Take care. Hope these videos are helpful to you. Please let me know. I appreciate that. Thanks for watching. Take care. Have a nice day.